Two concentric spherical shells have masses m1 and m2 and radii r1 and r2. What is the force exerted by this system on a particle of mass m1 if it is placed at a distance r1 plus r2 by 2 from the center? Fine. Now let's say this is my one sphere, the another one. The inner sphere has a mass m1 whose radii is r1 and the outer one is having a mass m2 with a radii r2. A particle of mass small m1 is placed at a distance r1 plus r2 by 2 from the center. Fine. Now one thing I should tell you, that if you are confused that this distance will lie from outside m1 or from outside m2, then I'll let you know that this can be written as r1 by 2 plus r2 by 2. Okay. Now if you feel that this particle m1 is outside m2, then the distance, that is the distance from the center, should be, let's say the distance is x, so the distance should be greater than r2. This r2 can be written as r2 by 2 plus r2 by 2. Okay. Now clearly this r2 by 2 is same over here, but the r1 is less than r2, right? So of course the distance x is lying somewhere between r1 and r2. Okay. This proves that the particle is lying at a point between the two spheres. Now what I have to calculate is the total force. So the one thing is clear, that if a particle of mass, whatever mass, is kept inside a hollow sphere, then the gravitational force between both of them will be zero. So the gravitational force will be only due to the inner sphere and the particle of mass m1. So it can be calculated by formula G into m1 into capital M1 divided by r1 plus r2 by 2 whole square. This is the distance between both of them. So the answer, that is the net force acting on particle m1, is given by 4 times of G m1 capital M1 by r1 plus r2 whole square. That is the answer.